Welcome back to ELE 111. This is week 2 of 5 weeks remaining this semester. This is the current divider material that goes along with chapter 6 and 16, 17, sections 4 and 5. I hope I find you well, safe, and healthy. Current divider is exclusively used for parallel circuits. I also want to tell you, don't forget, you can play these videos over and over if you need to grasp the material. So as the first line says, a parallel circuit is often called a current divider because it divides and proportionally appropriates the currents into fractional parts, which means percentages get shifted into different branches based on the resistance. So the circuit that you're looking at there that is circled in black and blue right now is a parallel circuit, and the 1K resistor will by default receive the most current. The smaller the resistor, the higher the current flows. So in parallel, there is no difference. Somewhere down the road, this is going to be a capacitor, an inductor, or in this case, a resistor. And ohms is ohms is ohms. That's the thing you have to keep telling yourself. Get the heck out of farads, get the heck out of henries, make everything ohms, then you can make calculations. Okay? So I'm going to leave this first page shortly here. You'll see down at the bottom in the red that they have made an attempt to calculate the currents that are happening in each of these branches. The constant in this is that the 6-volt battery is on the top of the equation for each branch. And that's what is consistent, but the resistors that go on the bottom, 1K, 2K, 3K, grow, and as they grow, the current shrinks. In slide 2, I will just basically go over this extremely fast and allow you to look at the numbers they're going through, and they're calculating not only the currents in each branch, the old-fashioned way, they're calculating the total current, and they have a calculation in box 3 where you can see that the total resistance of R1, 2, and 3, 1K, 2K, and 3K, is less than the smallest resistor. And since the smallest resistor is 1,000 ohms, 545.45 makes sense. The current through each resistor is related to the resistance. That's what we've seen so far. Now, if we change the voltage, as they suggest down here, if your battery becomes 12 volts, right now it's 6, but if it became 12, each of those currents, for example, in the green box here, 6 volts divided by 1K, if you doubled the battery to 12, the current, which is circled in red, would double. You say, well, so the currents change. They do, but each of these currents, the 2 milliamps would become 4, and the 3 milliamps would become 6. So the proportionality of what the resistors are doing, the division, the current division, maintains regardless. If you change the battery, the proportions hold true. Answer that's sitting over here in this box circled in black up at the top. Okay, so I'm going to let you read through this slide. Again, they continue to show you what I was telling you earlier, that the proportions through each channel are consistent regardless of the battery that's used. The current levels will change, but the proportions will not. Amps, is the same. We just calculate, go on to the current divider slide, and we see up here, this is basically a version of Ohm's law. This is a fact of a parallel law, a parallel circuit, that the voltage in a parallel circuit remains consistent. And that's where this formula called the current divider ultimately, let me get back here. This becomes the current divider formula. Very important, very, very important. Add it to your formula sheet and ignore all other current divider equations that you may see in your book. They may work, they do work. They will confuse the hell out of you, and you will never remember them. This equation that you're looking at with the black circle basically is voltage divider. Wherever there's a V, we change it to an I. Now, the other thing that's slightly different from voltage divider is the resistances are inverted. So the total resistance of your circuit is on top, whereas the current for the unknown channel that you're trying to calculate is on the bottom. So we have an inversion of the formula. 6 milliamp. And as you are able to read through here, you'll see that they basically take a circuit with an 11 milliamp current source. This is IT. IT equals 11 milliamps. And they take it and they divide it by the total resistance, which is 545.45, divided by 1,000. And it shouldn't surprise you that that answer using a different technique. We are using the current divider to do the calculations, and you'll see that all three of these currents are exactly the same using a different formula. So I'll leave the rest of it for you to read. Notice that the voltage divider and the current divider look almost 100% the same. Add them to your formula sheet. Good luck with future material.